in your nearby, all these all these segments are being taken care using smart sensors, right? Big data analytics and advanced algorithms. So now, as data has come into the picture, as smart sensors has come into the picture, of course, the big data will come, and data analytics, as I already discussed, we have so many requirements nowadays in the industries, in core mechanical industries for AI and ML engineers. If our mechanical engineers, electrical engineers, electronics engineer, or dedicated AI ML engineers are ready to take this challenge from the industry to design their model on real-time data, then of course this can help, and this is already helping. There is a lot of requirements from core mechanical, electrical, electronics students, but they should know about these recent technologies, and that's why it needs to develop the skill level of the faculty members as well. So let us work more on it. Let us make some association and let's help one another so that we can actually generate the environment of practical learning for these recent technologies in the country and in each zone, whether it is a tier 1, tier 2, or tier 3 city. Multi-level customers, interaction and customer profiling. It is the augmented reality and wearables. We know about it, like how the simulation is helping out, how AR, VR is helping out in before putting entire full-fledged production into the place. And then cloud computing. Yes, the data is on cloud, and there's huge demand of these people in the industry nowadays. We have data analytics as core capability. Digitization and integration of vertical and horizontal value chains. So these all things are there. Digitization of product and service offerings, digitization, digital business models, and customer access. So all this can help out. And route to smart manufacturing networks, horizontal integration through value networks. You can see some systems are there which is interconnected with multiple companies using just a computer system. Agile value chain, now agile manufacturing come into the picture, where the flexibility, more flexibility is there in the plant layout and different resource management and change of resources in the company as per the requirements in the market. So what kind of products are coming based on that? If you can make some changes in your company, if you have agile manufacturing setup, you can really make some changes in your company, and you can have multiple places nowadays. Earlier, there was a necessity that a plant has to be inbuilt with all the inside facilities. But now, if the space is less, anything or site selection has been done for doing certain different types of operations on a product, it has to be rotated to different companies. Instead of doing that, we can just flow the information, we can flow the design data, and we can get the ready-made things from the suppliers or contract manufacturing in nearby places. So agile manufacturing has really added, it has boosted the value chain in the manufacturing system. Vertical integration and networking manufacturing systems, so it has become the global version now. End-to-end digital integration of engineering across the entire value chain, right from product, machine, production, services, manage the people, culture, and leadership transformation, people 2.0. So now it has made us to think out of the box. What is that? That is just nothing, just developing our skills. Let us do more practice on, and let us understand the basics before going into the deep learning of this AI/ML technology, so that we can actually, when our students or we ourselves are well equipped or we are well trained on the various strategic models of these things, basic research we have done, then we can also develop some new products for the society, for these industries, and through the technology transfer, we can actually add value to the system. So people 2.0 is nothing but getting well trained related to these technologies. Yes, this was the thing I was talking in 3 slides back to you. how it has been divided into two things. One is physical and second is digital. So the digital twin connecting the physical and digital worlds. Robot is the best example to see. The robotic arm, when you see it, it has the physical as well as the digital things, utilizing some sensors and the controllers. You can control the machine with or without a remote control. With mobile phone, you can use, or a teach pendant can be used to do that. And uh, just to improve the efficiency and effectiveness of the machines, we need to go towards the digitalization. The 1 year caliper was digitized before 15 to 20 years or more than that. So what are we waiting for? We have all the equipments. We need to focus on that. I have one connect with Mortec machines in Ahmedabad. So I visited there a few years back and I saw they were working on a machine in the year of 2000 and must be 17 or 18. In that year, they were working on the machines. They were developing their own automation systems and they patented their machine. Their own machines, they only patented. They said no to China. They said no to Taiwan. They said no to Korea. They inbuilt all the things. They hired some AI ML people, IoT people. They hired the managers and engineers from various colleges and from different companies. And they developed their own ERP systems. They developed their own digital systems for the machines. And one by one, they started patenting their molding machines. In that time, it was happening. So now, what is our responsibility? The responsibility is only one. Let us understand each and every machine, how we can see. Now, invention is quite difficult. Innovations is possible. So towards innovation, let us understand, let us think out of the box and utilize these services, these learnings, and let us make everything digital so that we can improve the use case. We can improve the use case of those machines, and the acceptability of such kind of machines will be more in the industry in near future. So we can do this. Physical and digital, both are important. Physical will give the rigidity of the system, and digital will give more features and adaptability of the product or machine into the society. So now there are various levels as we have seen. So from bottom we can see automation processes. Level 0, 1 and 2 industrial automation. In the last we can see just bottom of this image. Manufacturing operations management. So how it happens, say discrete system, hybrid system, continuous system and batch production system. So these all are production systems. How you can make based on the ABC analysis of the various products, and you can make this analysis, you can utilize these, you can work on these automation in the industry, like they are already adopted it. There, you just need to go there and to learn from it. Through practice, we can learn more rather than just going through the slides and PowerPoint presentations. Better is to get into the company and understand what are the minute things, how we can generate, how we can learn more from their real-time challenges, right? Then level 3 is manufacturing operations management. So these are the terminologies or factors of operations management we have seen. Then enterprise business operations. So these all are basically related to the performance, capability, and supply and demand. So more of the business things, business processes of the company. So everywhere the IoT is supporting us. Factory model connecting the enterprise to the shop floor. So why is it important? Can anyone tell me why connecting the enterprise to the shop floor is important? But the condition is one, you have to enable your camera. Why shop floor has to be connected with the enterprise? There are managers to tell everything to the shop floor people. Why we need all these connections? Why shop floor should be well enabled with all the details all the time? Can someone open their camera and can please speak on this?
To increase productivity.
Mr. Ranjit, please, I would request you if you can please come on video camera.
Sir, to increase productivity mainly.
To increase the productivity, how? In what way?
Sir, when we install certain cameras or sensors, a sensor regarding IoTs and all,
Okay,
we can reduce the error rate in the industry, sir.
okay, correct,
Through that, we can reduce the increase the productivity and
correct.
whatever. Then terminology is there, sir. I'm not getting the terminology. But whatever scheduling we do in the industry,
Yeah,
that will be boosted up automatically.
correct, correct, very correct. Thank you, Mr. Ranjit, for giving me the right answer. Basically, the management knows about what is required at the shop floor, right? Because they are more connected with the marketing and sales team, and the demand comes from the sales team, and sales team is connected from the customers directly. The market trends and shifts, they know it better. So they only tell everything to the higher management that what is happening and what is required. And through that, all the information comes to the down the lane till the machine operators and supervisors. So now this connection is important. So how the information system we can boost? See, the services of the quality or the quality of the services required based upon the understanding of the last person in the company, not the first person. Understanding the last person that why I am doing this work today. What are the pros and cons of providing any dull quality or good quality on my, not only on my self appraisal, but what will it impact on the industry and to the society as a whole. So that special thing is required, and because of that, we need to connect the enterprise, we need to connect the business processes to the shop floor. The things related to quality of the product, dimensions of the product, specifications of the product, then sales after service. So we need to analyze the product and the machinery every time, every point of time, whether we are doing something wrong. So earlier we used to have our industries used to have different types of people with different expertise, and third party consultants also used to come, whether you are doing correct or not. Method study and work study was happening to the third parties earlier. Nowadays, there is no need. It is already happening, as you have very well told, Mr. Ranjit, that yes, there are certain cameras, there are some master schedules. These schedules can help out in analyzing the product and the services happening inside the company, and that actually helps, that boosts the business scale, that boosts the sales of the product. They promote the sales, they come into the marketing zone. And how is it happening? Just because the last person of my company, if he knows that why I am doing all these processes throughout the day, then no compromise with the processes, no compromise with the quality of the product will happen. And that's why a factory model nowadays is made with the philosophy that whatever things are coming from outside, let us have some learning and development wing in the company. This learning and development wing will work on, will analyze more data from the ERP, PLM, supply chain management and all, and then they will take some sessions for the engineers and managers. On the spot exercises will be conducted, and based on that, based on that, they analyze and they actually make the system what is required. It should be a worthwhile for all the products to get a good sales. I'm at the end of verge. I'm on the verge of ending this slide very soon, so I'll do it a little faster for next 3 to 4 minutes. From smart data to smart manufacturing networks. So smart data is available everywhere, right? But what we will do with it? A person in the company thinks that okay, I have done my job. My 9 to 5 job is over. Now I can go and sleep well. That time was old. Nowadays, people think I have generated a lot of data today with not only the product, not only to the process, but a lot of data has been generated because IoT is all around me. My manager and bosses and everybody is watching me through this IoT enabled things. So what is his concern today? You know, the concern is only one: smart data I have generated for them. They must be analyzing. And once the outcome will come, we have to put the right things or improve things into the manufacturing, and let us make a good network of all the manufacturing capacities and all the functions in the plant, so that we can have, of course, the higher productivity and higher return on the investment, and best workmanship we can achieve, best standards of quality and ISOs we can have in our company. And these are the things, very huge meaning for these words are there: smart sensor, smart machine, smart factory, connected factory, and smart manpower. So all are important. Vertical integration within a factory. So these are vertical integrations. You can see level 0, level 1. Level 0 is product, level 1 is field, level 2 is process control, level 3 manufacturing operations management, and level 4 business control. So we all are connected, right? Once we are into the industry, and you can see certain shop floor applications of IoT and devices like robot and equipment is necessary to enable production. Yes. So more automation, less headache, but more analysis of the data and more chances of getting what? More chances of getting more success in our workmanship. Horizontal integration between the factories, yes, one-to-one industry are connected. As I have told you, it is the modern era. Now, spatial economic zones are there in various industrial areas of the country. And as we can see in Faridabad, Noida, or we can see in Pune, especially in Chakan, Mahalunge, and Nanekarwadi, and all these areas. I have too much big list of these companies because I have worked for placements for so far. So these all spatial economic zone, whenever I have visited, I have seen there is cluster manufacturing concept, and the cluster manufacturing concept is what? Having all types of subsystems available in the same spatial economic zone for these companies, so that transportation can be minimized. Transportation of various goods can be minimized, and these clusters can be maintained when you have horizontal integration between the factories, and less time, less use of time, then less wastage of money will be there. Then of course we'll be having a healthier environment in our manufacturing ship. I am very close to end this slide. Big data analytics in smart connected factories. So you can see how many millions data is being generated from our workmanship, and this data is only the value today. And we need to value our students, being the professors, associate professors, assistant professors, lecturers, and technical experts, technical assistants. Our students are only the value, their brain is our country's value, and we need to develop them as per the requirement, as per the customized requirement of the industry. And IoT is one of them, artificial intelligence is one of them. Every data is into a loop. Whatever you are using today, you can just have you can take a snapshot of this picture, you can analyze it later on. Because of the less time, I am just going a little faster. Smarter analytics, improved resource and process performance. More questions you can have, you can ask me afterwards also. I'm there in the groups. You can ask any type of help also from us, anytime related to your product development or any kind of things. And still, if we have time, I'm sorry, Gopal sir, I have taken a lot of time in this session because I had a lot of things to discuss, but I cut it down in the last. I'm sorry for that, but I hope my viewers, my audience must be enjoying with this new learning, and they can have a little more queries. So the forum is open to ask any kind of question, and if the time is less, you can ask any time. Just say my number is there in the groups. Thank you very much.
Thank you,
Hello,
sir.
sir.
Participants, you can enable the video and you directly interact with the session speaker.
Hello, can you hear me, sir?
Enable the video, sir.
Yes, I can hear you.
Okay. Yes, sir. So how this IoT can be implemented for the legacy manufacturing, in the sense existing technology? So we all know for new technology, we can implement this IoT and all, we can bring it out. But existing,
Yes.
so is
Yeah,
this
please
so
tell, sir.
cost effective to implement in the existing one, sir? But most of the machines are not supporting with our new technology.
Ah.
So
So
how
what
it
is
is?
happening? Yeah, this is the cons of our thing. Like all the companies are not having agile manufacturing system, right? If existing systems, we need to update it. We need to make some automation. Like Motec machines have done it in Ahmedabad. Like we can also do. Like if you are, sir, may I know, are you from a company, from an industry?
No, sir. I am from CMR Institute of Technology.
Great, sir. So, see what these industries are doing. Like existing things are there. As I told, invention is quite difficult nowadays, but innovation is always possible. So, suppose I have this instrument. I just bring an instrument for you in my incubation center. I have this spanner, ring spanner. I have this hammer. Both are very conventional, but they are just good steel and they are having good aesthetic. But can I make them digital? Improvement chances are always there with everything. Now, if I go to the whiteboard, I will find some automation is already there, but are we really using it? So automation and innovation possibilities are always there in all the plants, but it depends how much money is invested, how much money is required to make changes in the system. And automation is possible, sir, because I talk about myself as well, because I have made nearly 10 plus projects throughout my journey of this career. All are fabrication projects, and the existing machines are already available in the market, but we have always made our own machines and we have developed with some more smart features. So possibility of innovation is always there, sir.
Yes, sir. That I do agree. But thing is that is that a cost effective instead of making a new one? It makes sense. So it is a cost effective, but existing one to making a modification and it will again it will incur some kind of cost. So everyone,
It will
whatever the
incur, sir.
technology will implement, finally we look into the effectiveness in the cost and time.
Exactly.
So if it is
Exactly.
not effective in a cost, then so better manufacturer will think in that manner. So he will leave. So instead of
Hmm.
going for, because we have faced so much of problem in, so you called additive manufacturing, we worked on metal additive manufacturing. So there in that,
Okay.
we wanted to bring a new features in that. So it was increasing, the cost was going high. So instead of that, we thought of to buy a new one.
Hmm.
So that was
See, sir.
my query.
See, sir, using some raw material, like my students are making, still manufacturing is going on in the basement of my office. The students are making some smart wheelchair and bed. So they are also making their own product, and they are making, see, things are available in the market, but they are making it their own. Now, existing system you have, suppose lathe machine you have in your system, right? It has been automated also. But whatever automation you will add, it will of course add some money. Now I talk about this product. This product is one of the top 100 accepted product at some American contest last year. It was funded by our chairman, sir. Seed money it has been given. Now most of the products are imported, sir, from outside because India is not manufacturing. Now what is our responsibility? Now today one student has made some model. These models today only I have got from my students. My first semester students are making these products. So this product has been made, and just 1 hour back only this machine has been given to me, and this is just nothing but the metal detector. This machine is actually spreading some seeds on the agriculture field. So they are making such prototypes. Now the machines are already there, but whatever product you will add, of course, it will add some cost. Yes, but you need to develop your skills how we can use some other existing components so that we can reduce the cost. We cannot add too much of cost, but we can get the most outcome of it. That is possible, sir. But we need to brainstorm more on those things. What are the existing devices available to improve the existing machines so as to get the best solutions out of it? Possibility is there. Of course, cost will be added, but we have to go with the automation because once the technology transfer will happen, we can just do the preliminary research. Rest of the things will be done in the industry.
Okay, sir. Thank you so much, sir.
Yes, sir.
I
Good
hope
evening, sir.
I gave the right answer, sir.
Sir, good evening, sir.
Good evening, sir.
Sir, this is Dr. Arun Manohar from Gift College, Bhubaneswar. First of all, your session is very informative. I've enjoyed a lot, sir.
Thank you, sir. Thank you.
Congratulations on that. Sir, I would like, so as you told that you have worked with so many industries where you have updated from the, I mean, you have, when you upgraded the industry from the conventional to the IoT based and all. So just I would like to
Yes.
know what were the challenges, sir, what were the challenges that you faced when you are implementing this IoT in the existing industries, sir?
See, sir, my PhD topic is in statistical process control. I have done my project at PMT Machines Limited, Vadodara, right? Now there we found one problem. The problem was with the calibration scale of whenever the CNC machine had to take vertical movement in the Z direction. That time, because the calibrated scale was not there in that machine, the machine was manufactured by the company, and Delphi TVS Chennai was was going to purchase that CNC machine from us. So that time we came to know that the machine was calibrated. A normal scale steel rule was provided with the machine, and they were doing some we tell in Hindi as jugaad technology. So they were working with that. But what I found when I was going through all the causes, when I was measuring all the causes of variations in the dimensions of those Delphi TVS Chennai's cam roller shoes. So I got to know there is some chances of variations, and some extra chart I plotted what I learned from my IEM during my MTech, and I was a faculty as well during that time as a resource person. So that time I checked, and then the deputy director of design and me, and we all sat together and we come to know that yes, if we have certain sensors, so with sensors after calibrated scale using sensors, when we made it, because their design development department is very huge and they had all the support systems, we implemented those things into our CNC machine. And after that, how many trials we have done, sir? You won't believe we have generated the cam roller shoes, same cam roller shoes from the same machine with advanced sensor based this calibrated scale. We have generated the product variations with 1 micron. Sir. We were able to produce the product with 1 micron tolerance.
Wonderful, sir.
And that was
Wonderful.
happening.
Okay, sir.
That was happening. I have done this practical there.
Okay, sir. Thank you, sir. Thank you. Thank you so much. Thank you.
Thank you, sir. Thank you, sir.
Thank you, sir. The participants, those who are having the any queries or doubts, you can post it in separately. You have to send in this group, or you just directly mail us. So we will answer for these questions. So due to the time constraint, the second session also we need to start. We are in the position. I hope everyone understand the situation. So I request to the participants, you kindly send this queries to the mail ID. I already shared in the mail ID. So we will get the answer, and we will get back to you. So thank you, sir.
Thank you, sir. Thank you so much. Thank you, everyone.
Thank you, Piyush, sir. It was a nice presentation.
Thank you, Raghu, sir.
Participant, I will, Dr.
Yes, sir.
Hemant
Thank you, sir. Hello, everyone. This is Dr. Hemant Raju. On behalf of New Horizon Management, Principal, Dean, Director, HOD, and faculties, I thank the session speaker, Dr. Piyush Kumar Soni, sir, for his nice presentation, and also is taking his time on transferring the knowledge on the topic, integrating IoT in the production processes. It's a great learning for all of us. Thank you very much, sir. Thank you all the participants for joining the session. I also thank ACT Atal for giving us opportunity for conducting this program. So I'm hereby posting the feedback link and the quiz link. So I request all of you to fill the link, and the link will be active for another 20 minutes. I request all of you to kindly complete it. Thank you, one and all.
Thank you, sir. Continue this. The second session going to be start 7:45. Take a 5 minutes break. So the second session will be given by Mr. Rogit Tyagi Arsu. So we are waiting for their presence. So take a 5 minutes break.
Professors, if anyone is interested, you can just give some feedback about Piyush sir's presentation in the video mode.
I would love to know that. I'm not gonna, I'm here only.
Hi everyone. Hi Piyush sir. Hi Dr. Gopal. Hi Raghuji.
Hi, sir.
I heard this session, and one thing that really was very interesting about this session is that sir was able to make a connect between the management aspect and the engineering aspect, which actually is required. Because when we talk about the management, efficiency, productivity, and effectiveness, all those things, they are the ultimate goals. And sir has given a very nice connect, and the vertical angle and the horizontal angle, all those things, they actually were very nice. And I could make a connect like which I was actually expecting from the session. It was a wonderful session. Thank you so much.
Thank you,
Thank you
sir.
so much.
Thank you so much, sir. It means a lot to us. Certain opportunity we look for, like
Definitely, sir. Definitely.
interacting with faculty people at this platform, and so many people are there from various corners. So we really like to interact more.
That's right, sir. Sure. Thank you so
I'm
much.
sorry, I made a note of it. Thank you.
Thank you, sir. Gautam, sir.
Sir, Gopal sir, tell me.
Sir, I welcome Professor Gautam Raj, sir, to give the
Sir.
introduction for the next speaker.
Okay, sir.
Sir, I hope participants were joined. So now you can introduce the next speaker.
Okay, sir. Okay. Good evening, everyone. Greetings of the day. It gives me the immense pleasure to introduce the esteemed speaker of the day, Mr. Rohit T. Mr. Rohit T is presently working as a Deputy Manager in Vodafone Intelligence Solutions from past 12 years. He has got 12 years of experience in cybersecurity and providing a security services for UK, Europe, and African regions. So I welcome Mr. Rohit, New Horizon College of Engineering, Bangalore, to deliver a talk on the data analytics in manufacturing from data to insights. So over to you, sir. Thank you.
Thank you, sir. Thank you for the warm welcome. I hope I'm audible to everyone.
Yes, sir. Audible, sir.
Yes, sir. Yes, thank you. Hi, let me share my screen. Okay. Hi, everyone. My name is Rohit. I work as a deputy manager for Vodafone Intelligence Solutions, and my primary area of focus is cybersecurity. I'm responsible for maintaining the data of Vodafone and all its customers, and we work across Europe, UK, and African local markets. So today I am here to deliver a lecture on data analytics in manufacturing. So since it is a vast subject, I'll try to cover most of the things. I would like to start by giving getting to the basics first, and then moving on to the industrial level applications. So this is the agenda for us today. So the first is the introduction to data and classification to data, and then we move on to the data analytics process, the types of data analytics, and a case study, and also the takeaways and conclusion. So let's start with data. So I'm sure most of you have heard data and consume data all throughout your lives every day. Okay, so data is a collection of discrete and continuous values that convey information. So it may be used to describe a quantity, quality, it may be a statistic, it may also simply be a sequence of symbols which can be interpreted. So mainly data what we use are in the form of numbers, characteristics, or pictures, etc. So when you want to convert this data to information, you need to do some analysis. You need to combine this data, and you might need to combine with a second parameter in order to extract meaning or give meaning to it. Without which it will just be a simple number or just a character. So how do you classify data? So, and why do you classify data? So data classification is broadly defined the process of organizing your data into relevant categories. So why do you have to do this? You have to do this because you need to locate it easily and retrieve the data when you need it. That's the first point. The second point is you have to do a classification of your data in order to maintain the data security and compliance. So data security is at most important when it comes to industrial standards, because for example, you go to a hospital, they have all your data. They have all your medical reports. They have your credit card details. They have all of your personal details, PIA information. So this data has to be classified in such a way that it should not be misused by anyone. So in terms of industries, you classify them as C1, C2, C3, C4. Many of you would have heard this. So based on the confidentiality of the data, you would classify them, and you would make sure that these data are stored in locations and secure locations, and only the public available data is shared to everyone, and not all the data is shared to everybody. Data is shared on a need to know basis. Okay, and data also involves tagging. You tag the data for accessibility and tracking purpose. So you have your financial data, and you have your personal data, So all this different types of data have to be tagged, so it can be easily accessed and tracked. And also classification of data eliminates duplication of data. Duplication of data is a very huge problem when it comes to storage, because when you have duplicates, your storage increases. When your storage increases, you will have to spend more money for storing this data, right? And we look at the different types of data that we have. So data are classified from structured to semi-structured, quasi-structured to unstructured data. So you see the structured is at the bottommost part, which means a very tiny portion of the data is structured. And then we and then we move on to the semi-structured, which is a little more, but it is in the form of spreadsheets or your XML files. And then you have quasi-structured, which is even bigger than your semi-structured data. And then you have the unstructured data, which is majority of data which exists today. So if we take a look at the structured data, it refers to a data which resides in a fixed field within like a file or a record. Okay, so as you can see, the below picture, structured data typically is stored in a relational database. So many of us would have heard the RDBMS concept, and here the numbers, texts are fed into the table-like structure. So this feeding can be done automatically or it can be manually done depending on your application. And in order to extract this data, in order to modify this data, you would have to use a programming language called as SQL, the structured query language. So basically, the structured data is only around 20% of the data which is structured. And you can say a vast majority of the data is unstructured. And when you come to the semi-structured data, this falls between the structured and the unstructured data, like we saw in the picture earlier. So this does not reside in a relational database. Okay, but they have some sort of properties which helps you to analyze the data easily. So just like your XML files, your emails, your server logs, these are typical examples of your semi-structured data, which is a little bit flexible when you compare to the structured data. Structured data is very rigid, but this is a bit flexible. So this strikes a perfect balance between your structured and the unstructured data. The next is your quasi-structured data. Quasi-structured data is mostly a very erratic data format. So this, for example, quasi data structures can be your clickstream data, your Google search results, your web scraper data from all the websites. For example, you open a web page and you go to a different sections of that particular web page. These data is collected. This data is, for example, if you are on to Amazon or something and you add some objects or some products to the cart. So all this data is collected by Amazon to track the user data and what people like to buy, what people are going for on a particular season. So all these data are called as quasi-structured data. And next comes your unstructured data. Unstructured data, as the name suggests, it is not in a structured format. Okay, it does not follow any sort of standard, and it does not have a particular format. So it is kind of a formless data. But this typically requires some sort of pre-processing by the computer to understand this particular data. For the computer, it is very difficult to understand this data, but for from a human perspective, this it is easily understandable because it is mostly all this customer reviews, images, videos, your emails and tweets. All these things are easily it can be understood by us, but it is very difficult for a computer to understand. So it requires a lot of pre-processing to understand this. So here we can see the difference between the structured data and the unstructured data. So basically, as I said, structured data is displayed in rows and columns, and it is residing in a relational database, whereas your unstructured data, it cannot be displayed in rows and columns. So structured data consists of numbers, dates, and strings. Your unstructured data consists of images, audio files, video files, your spreadsheets, etc. So according to Gartner, which is a popular research and consulting firm, 20% of the enterprise data is in the structured format and 80% of your data is in the unstructured format. So your structured format, since it contains only the numbers, data, and strings, it requires less storage. And whereas in your unstructured data, it requires a huge repository where you can store all this unstructured data. And also it is easy to manage and protect with your legacy solutions. But in the unstructured data, it is more difficult to manage with your legacy solutions. So tools for working with the structured data. So yeah, I'm sure most of you will know these symbols is SQL, SQLite, Oracle, and OLAP, Online Analytical Processing Tool. And these are some of the tools which are used for your unstructured data: Hadoop, DynamoDB, Azure, and AWS, and MongoDB. So now that you know what is data, how is it classified, now comes how do you store data? Storing data is also a very important because it involves a lot of cost from the business perspective, and also from the safety point of view. So so how do you store structured data? Typically, structured data is stored in your data warehouses. The data warehouse is the last is the end point of your data's journey. So once you extract information, transform it, and it load it, the last point where it gets stored is your data warehouse. And since it is structured, it requires less space. And we've already seen the RDBMS part. There is something called as data lakes, which is used for storing your unstructured data. So unstructured data is something which is very, very huge because you contain audio, video, data, and everything. So you need a data lake to store all this data. Okay, so you have to perform a cleaning process first before you can store this. So what cleaning process is basically removing out all your corrupt files, files which are which can to even duplication of data. So that is also a problem, right? So you have to clean all this before you store the data into data lakes. And and this unstructured data, it does not fit in a relational database. So it is more into a non-relational or a NoSQL database. Yeah, and now we move on to data analytics. So now you have all your data, but it is in a raw form. Okay, so data analytics is the science of analyzing the raw data to make conclusions about the information. So data analytics, how does it help your business? It helps you to optimize your performance. It helps you to perform more effectively. It helps you to maximize your profit. And it also helps you to make strategic decisions for your future. So the techniques for processing the data analytics have been automated because data analytics is on the raw form. It is very hard to consume. So you do have to automate it so that you can understand the data. So you have to rely on software tools. Software tools from basic spreadsheets to data visualization tools or even open source language. You can write your own code to process this data. So you have a lot of tools available now, which helps you to do the data analytics part. So from the raw data, you apply a software to do your data analytics to get the final output. So data analytics technique, so they can reveal trends and metrics that would otherwise be lost in mass of information. So you have a lot of information to go through. Getting the data is one thing, but going through the data, you spending so much of manual effort in going through all this data can be very difficult. So that is where your data analytics comes into picture. And for examples, in the manufacturing industry, you can record runtimes, downtime, and your work you from various machines. You take a service line, you take all these readings, and you take all the data, and when you apply the data analytics part, it helps you to better plan your workloads. It helps the machines to operate in the peak capacity. It also helps you to minimize downtime and breakdowns also. When you go to the gaming companies, so what the basis of the gaming company is to keep you uh, hooked to this particular game. They don't want you to log out. So what they do, they set up some sort of reward system. So as you further into the game, you get rewards, so that this keeps you wanting for more, and you play the game. And they want to keep majority of these players active in the game. They don't want you to go out, right? And even the content companies like your Netflix, your Amazon, even your YouTube feeds are customized according to your browsing data. Uh, and even a bit further, they even know what kind of devices you use. So based on your devices, they change the bit rate, they change the videos that you are going to watch next. They predict what kind of videos you like, based on which your watch list keeps on increasing, right? They don't want you to cancel the subscription. So this is how the data analytics work. So and also data analytics helps the business to optimize their performance. Okay, they help you reduce the cost, and they help you identify how efficiently business can be done, right? So coming to the data analysis process, um, you have 6 steps to do the data analytics, right? The first step is defining the objectives and questions. So what I will do is I will give you an example side by side as we go through the process, so it'll be easier for you to understand. Okay. The first step in the data analysis process is to define the objectives and formulate a clear, specific question that your analysis aims to answer. So basically, you need to figure out the problem that you're trying to solve. So that is the first step. So for example, you work for a bicycle company, right? So the example that I've taken here is the first step that your company wants to do is it wants to improve your bike sales, right? That is your first step, defining your objective. Your objective is to improve the bike sales. So the second step is to collect the relevant data. So how do you collect data? You can collect data by various methods. You can do surveys, you can do interviews, you can take the data from your previous sales, from your existing database. Depending on the nature of your problem, you can reduce your data set. So for this purpose, what they've done is they've taken the year, month, and customers, what is the customer age, customer gender, and the location of the sales where it happens, and the products, which products is selling more, and the subcategory of products what they're selling, and also the sales metrics. So the quantity, the unit price, and the revenue what they've got from selling these bikes during a particular period of time. Everything is, this is the data set that you've taken. And the third step is your data cleaning. The data cleaning is a very crucial step because you don't want to go through all the data, right? So based on your question, based on the problem that you're trying to solve, you take out the data which is irrelevant, which is not required, uh, which is inconsistent, basically. So based on the data that you're taking, based on the more accurate your data, the more accurate analysis can be done to answer your or to give a solution to your problem, right? And the fourth step is data analysis. So once you've taken then the data is taken your data and you cleaned everything out, you use mathematical techniques or discovery patterns and relationships or trends, okay, uh, by using any software which is available to you based on your industry. There are specialized softwares like SPSS from IBM, then there is Kaggle, there is Tableau, there is Power BI from Microsoft, and you also have your open source like Python, R, programming languages for doing this type of analysis. So you can pick your tool according to your need and then start analyzing things. And the step 5 is your data interpretation and visualization. So after the data set, whatever I've shown, after the data is collected, you want to put it in a graph format. This is very, very important because you are ultimately going to present this to your stakeholders, right? So who might not be a very techy guy. He might be from a non-technical background. So it is easier for them to understand these sort of charts, right? So from this, what we can see is we have almost 50-50 ratio from both female and male genders who are your customers. And the range of customers who are maximum is between the age of 30 to 40, and the countries, the top 4 countries where your bikes are being sold, you is listed out, and what is the product which is being sold. The first is your accessories. Accessories are the number 1 sales, and next comes your bikes, and the third is your clothing line. And out of all these products, the subcategory, which all the subcategory products which are sold the most. So the tires and tubes comes first, and the bottles and so on and so forth. So after your uh, after your visualization, you have to, the 6th step is data storytelling. So what does this data tell you? So if you see the graphs, what it shows is from January 2015 to June 2015, the sales were not doing very well, okay, because they were only selling bikes. After July, the sales have picked up. Why? Because they've introduced 2 more things. One is the accessories from the same brand and also the clothing. So if you see, the sales have really picked up well, and the accessories is really doing well. So that it's going high all around. But irrespective of the bike sales are almost at a constant level. Okay, and this is your profit margin. So as you can see, the product category is broken down into 3 pieces. For the first is your accessories, bikes, and clothing. You can see for the most part, uh, the accessories are doing very well. So your profit margins is around 20, more than 20%, right? And your clothing line also is doing very well once after you introduce them. But your bikes have slightly increased from 2015 to 2016. Now, your company, they want to increase the sales of the bikes. So what can be done? So what they do is when a product is not doing very well, typically what they do is they do a lot of promotional activities, right? So they have done their promotions and they've got this data. So the first uh, column that you see is the orders that they've received during the promotion and the orders that they've received after the promotions. So if you see in France, mostly everywhere the sales have gone up. except for France and the 50 up population. Everywhere the sales has gone up, and also the United States, where you see a negative for the young audience from 20 down and to 20 to 30. So what can you do to increase your sales? So what they have done is, in France, what you can do is you can maybe introduce a special discount for your senior citizens. So this will boost your bike sales. Or when they buy a bike for their children, probably they can get a discount, right? And in Germany, you don't need to do much because it is already going up, right? So you probably you can introduce a premium product for which you can charge more, and then your sales might pick up. And even in the UK, the sales are doing very well. But for the United States, the sales have gone not very much, right? They've gone down probably. So what you do is you do promotions for the college kids, the new graduates, and people who are doing new jobs. So you can that way you can attract more customers. And in the UK and Germany part, maybe you can reduce the promotions as well, which will reduce the cost of your ads. In this way, you can increase your profit margin and you can take your business. So this is how a problem is solved, the sales problem, right? And this is a typical dashboard from your Tableau. Tableau is one of the tools that we use for data analytics. So here you have a 40-year data worth of information showed in a single dashboard. So you can see the top selling games. So who is your publisher, who's on top, which platform is doing well, and all that. This wouldn't have been possible without the tools. If you have to go through the raw data, this would take forever, right? Yeah. Coming to the data analytics, types of data analytics, you have 4 types of data analytics. Okay. So depending on your problem, you can choose what type of analysis you want. So the first one is your descriptive analytics. So what happened? If you want to find out what happened, you take descriptive analysis. And why did it happen? So this is more of a diagnostic point of view. So this is a diagnostic analysis is done. And what will happen? This is more of predicting the future. So you take predicting analysis. And then how can we make it happen? So this is for your future business, right? So you use prescriptive analysis. So in your descriptive analysis, you do a physical examination of your historical data to better understand the changes which have occurred in your business, right? This is basically doing, looking back at your historical data, which will determine, this is the foundation after which you will go for a diagnostic, predictive, and prescriptive analysis. So for example, if you take a production industry, you can refer to the time series data which is gathered during the production, okay, which will give you a view of performance, right? And the production data is gathered from variety of different sources and processes, including your production environment, by using sensors from equipment, monitoring systems, and etc. This will allow the process engineers to easily analyze the process and answer the below questions. How is our production process performing? Is it to the optimum level or not? How often did this problem occur? If there is a problem, if you look at your historical data, you can see how often does it occur. What is the root cause of this issue? Can I monitor deviations for good behavior? Can I predict when maintenance is needed? And next is your diagnostic analysis. Diagnostic analysis is a step further than the descriptive analysis. It is to determine why something happened. For more detailed exploration and comparing different data sets to understand the cause of a particular outcome. So for instance, if a company's sales dropped in a particular month, diagnostic analysis could be used to find out why, right? The diagnostic analysis can be helpful in any industry, from manufacturing to retail to healthcare. So after applying the diagnostic analysis to discover why this event has occurred in the company it can use the knowledge to create solutions and to develop the predictive models for the future. The manufacturing companies are depending heavily on preventive maintenance. Using time-based, use-based program, companies ensure fewer unpredicted breakdowns. So when you know why it has happened, you can predict when it can happen next. So based on that, you can do your maintenance and you can prepare for any unpredictable breakdowns, or you can do maintenance before the breakdown happens. Thus, you reduce your downtime, right? And increase your productivity. And you can also reduce the cost of maintenance. Next is your predictive analysis. Predictive analysis uses statistical models and forecasting technique to understand the future. Okay, from the past to predict what can happen in the future. Okay, so predictive analysis is used in the manufacturing industry in the following areas for quality control. For example, a car manufacturer may use predictive analytics to analyze the data from sensors to detect anomalies in the production process. Okay, they can forecast potential issues and take corrective action before the defect occurs. In the inventory optimization, so an electronics manufacturer, for example, if they have a demand over a certain period of time of the year, so what they can do is they can forecast demand and they can have their inventory ready. They don't have to overproduce it, or they don't have to worry about the risk of being stocked out. Right. And also you can use it in the supply chain management, production planning, maintenance and repairs, etc. So for production planning, for example, take an example of a food manufacturer. If a particular type of food is, is in demand for a particular season, for any sort of festival season, they have to make sure the inventory is there, right? And the raw materials is there to meet that particular type of production. And so that they don't waste by overstocking, or by running out of stock, right? So, for example, in Volkswagen, right, in December 2015, they had to recall more than 3 lakh cars, which was at that time the biggest, right? Because RI had found that the EA189 engine family was fitted with a defective device, which led to the emission of excess nitrogen gas. So you can imagine the amount of money that was lost, and also not only money, you lose your reputation, right? When something like this happens to your company. And also in 2014, Maruti had to recall a lot of cars because they had a faulty fuel filler. So by using data analytics, you can reduce these kind of accidents and these kind of mistakes, right? And the next is your prescriptive analysis. Prescriptive analysis is the most advanced type of data analysis. It helps the organization to predict the future and how you can achieve. Right. It is the most sophisticated type of analysis which you need to use your machine learning and the artificial intelligence. So there are few companies who do this. You have IBM, you have AWS, and what they do is they apply mathematical models and algorithms to recommend the optimal action to be taken by these industries, right? Prescriptive analytic techniques such as decision optimization can tackle highly complex problems ranging from hundreds to millions of constraints. This can never be done manually. It is highly impossible to do it manually. So the decision optimization technology makes it easier even for a non-technical guy to factor in the trade-off multiple objectives and work faster and to get a better results. So it can also help you answer the questions like what maintenance should be done to avoid the predicted future failure in the machine. So should we reduce the stock what we have and introduce new products? And what activities should be assigned to workers and when? And how much overtime will be necessary for a specific period? So these are all the questions which can be answered using the prescriptive analysis method. So, for example, a company called as Fleetride, they worked with IBM. Okay, they are one of the largest distributor of truck and trailer parts. Okay, so they have a huge factory where they have to distribute the trailer truck parts on a daily basis across the North America, right? So you cannot just randomly uh, uh, deliver parts just like that. You have to optimize your warehouse locations, where to stock up, and what is the shortest path to deliver these products. And you also have to minimize the delivery time, and you also have to minimize the cost it takes to do this. So they had partnered with IBM, which helped in the optimization of the supply chain management, which saved a lot of money. And also, you need the company um, will try to reduce the cost, right? They want to reduce the cost, but they want to get a higher revenue, and also they want to reduce the labor. So data analytics will help you do all this. So this is one of the case study which is taken from Mitsubishi. So there is their client, Mitsubishi's client is a chip manufacturing company. So they had a problem. So the problem was is they are a chip manufacturing company. They use material to coat these chips. Okay, typically how it is done is inside a vacuum chamber. So what they do is they introduce the heat source to the target material, and that since it is a vacuum, the target materials rise up and they stick to the chip, right? And depending on the thickness which is required, then the film is deposited onto the chip. Okay, so since they are into mass production, the problem was they had to do a pre-check every time before starting mass production, and then they had to stop production. Then they'll have to take the chip, then test it for contamination if it is within the acceptable range or not, and then they have to, if it is acceptable, they will continue the production. If it is not, they will have to clean the chamber before doing getting into mass production. So what they wanted was they wanted to predict the end quality results without pre-testing. They did not want to do pre-testing. They wanted to minimize the pre-testing as much as possible to avoid the downtime so that they can increase the production. And the problem was the end quality of the chip depended largely on the internal environment of the vacuum chamber. Right. So the customer expectation was the customer didn't want to change the setup. They didn't want to change any programming of this particular machine. They wanted the setup to be as it is. They didn't want to use any customized software. They wanted to use a off-the-shelf software to do the data analytics for this. And they also wanted their employees to be trained so that they do not have to consult Mitsubishi every time. Right. Then they also had plans for future projects where their employees themselves, they can do the data analytics instead of depending on a third-party vendor. So first, what they had to do was they had to identify the parameters which was affecting the quality of this particular chip. Okay, so what they did was basically when you do a project like this, you have to the data scientists have to align with the people who are actually in the production process. Only if they both work together, you can identify the solution to this problem. If the data scientists, they work alone, or if the production people are not, if they do not basically do not work together, you will never get to the solution, right? So there was a regression analysis which was done, and they were able to identify 60 parameters which was involved in the chamber environment, which affected the quality of their product. So regression analysis is basically a statistical method to understand the relationship between a dependent variable or to one or more independent variables, right? It is commonly used for forecasting, right? So they worked with each other and they identified 60 parameters. So out of 60 parameters, after doing the data analysis, they were able to finally come to a 3 parameters which were crucial for the quality of the chip. Okay, the first is the pump exhaustion time, second is the open air time, and the third one is the cleanliness of the crucible. So data analytics was key because they could disregard all the 57 parameters and they can stick on to these 3 parameters, which reduces your data set, right? And all these parameters, what you do, you feed into an edge computer, which looks something like this. And once you feed this, what happens is if these 3 parameters, it will give a signal as whether you can proceed, whether into the mass production, or you stop it and you clean the crucible before you proceed. Right. So these 3 parameters will be fed here, and this computer will basically tell you to go or not to proceed with the mass production. So by doing this, they were able to reduce a lot of pre-testing process, because if you do pre-testing, you have to stop the entire production line, right? And they were able to save up to 36 million Japanese yen. And then they also reduce the machine operation time of up to 360 hours, which will reduce your company resources as well. And they were able to completely eliminate the pre-testing process. And this is one of the examples how you could use data analytics in your manufacturing industry, right? Yeah, and coming to the takeaways. So digital data is increasing every day, right? Every day your data is being collected. So the market value is about $100 billion in 2003. So you can understand this is only expected to grow exponentially, right? And data might be too large or too complex to process. With data analytics, which can turn raw data into valuable information for the company and your business. Okay, it has become a main driver in competitive business world, can be used to our businesses, sales, and operations. So the top 5 sectors who are utilizing data analytics today is your finance and banking, healthcare, retail, e-commerce, manufacturing, supply chain, and transportation and logistics. So at this point of time, these are the 5 sectors which are utilizing this, but it is only expected to grow further. So basically, what you need to understand is analytics is not an IT project, right? You have to invest fully. The business must fully invest in order to get your results. If you just do it as a project, you will not see any results, and it will be just a waste of your money and time, right? So always start with the question, what problem you're trying to solve. Based on this, your entire data analysis process sits, right? If you start asking the right questions, you will get the right answer. If you start asking the wrong questions, obviously you will end up with the wrong answers. Keep your initial implementation modest. Whenever you are trying to incorporate data analytics into manufacturing, we always recommend it to be a simple implementation, right? Not to, take a very big project when you're going for it. And also determine the implementation objectives and your ROI early. Okay, you have to determine your objectives, and your return on investment should be very quick. Because when it comes to business, you will not only have to answer to your boss or your department as well, you will have to answer to the people who are giving you budgets, right? Your stakeholders, they are very important. So the results have to be quick, right? And you have to be the implementation should be very modest, so that you don't spend a lot of money and get and the management might not be very happy with it. And you need to always review and cleanse your data regularly. Your data will be coming in every day, right? You need to know you need to do a cleansing of it so that you can remove unwanted data. That is very important because your storage cost is also involved. And the last two things are make data available and make data actionable. The data should be available to everyone, right? You might have multiple teams. You might have your electrical team, your uh, maintenance team. So everybody should be should know where the data is, right? So the data should be shared. Only then you will get a proper result, and you have to make the data actionable. There's no point in just having the data and the data sitting in the repository, right? You have to um, act on these in this data, right? So yeah, that's the end of my presentation. Thank you all for listening.
Yeah, thank you, sir. I have a small doubt
Yeah,
regarding that is in manufacturing field.
yeah.
So
Sir,
how is it
enable your video
possible?
with your permission.
Yeah, sure. Yes, sir. So how it is possible to achieve high level of accuracy in predictive models, sir? Because in manufacturing, they are dealing with the varieties of manufacturing processes, not only a single process. So how it is possible? Because whatever the data analysis you are dealing with is a single manufacturing. But if they involve multiple processes, yeah, I felt it is little difficult to get a higher accuracy of data for different manufacturing process. Because loss of the data, sometimes it leads to the large impact on the predictions and model predictions.
Yeah, that's right. Because uh see because you have a number of teams involved, right? You have multiple processes. So you will have to um take a single process first, and then you will have to try it out there, and then you can move on to more complex process, right? You cannot expect uh, data analytics to solve all your problems. So you have to take a single production line first, and then you implement it there, and then you take to a different multiple production levels, right?
Yeah, that's fine, sir. But thing is that in manufacturing, no, most of manufacturing continuously they'll be changing the products. When product changes, processes always it will also change. You can take an
Correct.
example of car. Okay, the now
Hmm.
every 6 months or 1 year they are coming up with a new model, new systems. So implementing all those data's implementation for each itself, it will take a lots of time. So by the time next
Yes, sir.
product will be ready.
Yes.
So there, yeah. So I have quite doubt in this process aspect. Suppose if I am owning a company running with a single model, single product throughout the year, okay, fine, I can bring this kind of data analytics and I can improvise. But most of the
Hmm.
companies, they are having a wide spread of products. So continuously one or the other in a single ship, they'll be developing 3 different cars.
Yeah. Right, but the data whatever you're taking is based on your current production line, right? So
Yes, sir.
yeah. So as and when you change the product, the data also will change according to it. And then
Yes, sir. Thing
yeah,
is that collection, see, one example, Tata Nexon has come in 2020, right? So new model
right.
in 22 modified. In 24, it completely changed the entire outer sector, right? So there
Yes.
every year they're bringing the new things in that. Just one example.
Hmm.
So every time collection of data, implementation again, so bringing it into the implementation into the new system. So it is quite expensive or it is economical.
Uh, So it is, yes, you if you are changing the product and if you want to stay in business, sir, you will have to you will have to collaborate and you will have to use the latest products. But when you change the product, the data also changes accordingly, right? So the company, yes, they are reluctant to change very fast. It takes time for them to change, but once they get to know the benefits of this, they will of course have to move, because this is the way of the future. You cannot say say no to it, because you have your other competitors as well, right? So you have to adopt these methodologies, even though if it is a little bit expensive, you do have to do it in order to stay in business. And some of the companies, they are having their own data analytics engineers. They are hiring their own R&D departments to minimize costs. Like if you see Netflix, they have their own R&D team. They are not dependent on any third party. So similarly, in the manufacturing sectors also, we will have to spend more on R&D. We will have to train engineers. We will have to all work with data analysts to reduce cost ultimately.
Okay, sir. Thank you so much, sir.
Thank you. Thank you.
Thank you, sir. Participants, if you have any queries or doubts, you can post the questions through mail also. So we will collect the entire data and we will get these answers, and it will be revert back to you through the mail. So Hemant Rai, sir.
Yes, sir. Thank you very much, sir. Thank you for the session. So, hello everyone. This is Dr. Hemant Raju. On behalf of New Horizon Management Principal, Dean, Director, HOD, and faculties, I thank the session speaker, Mr. Rohit Tyagi Arasu, sir, for his taking his time on transferring the knowledge on the topic data analytics in manufacturing, from data to insights. So, it's a great learning for all of us, sir. Thank you very much, sir, for this session. Thank you all the participants for joining the session. I also thank AICT Atal for giving us opportunity to for conducting this program. So I'm hereby posting the feedback link and the quiz link now for this particular session. I request all of you to kindly fill the link, and it will be enabled up to 20 minutes. I request all of you to kindly fill it. So thank you one and all. Thank you, sir.
Sir, I request Sony sir just to give the feedback about this session.
You want me to speak?
Yeah, just a feedback about this session.
Sir?
Pleasure to.
Session was brilliant. Session was brilliant, and Rohit sir was excellent when he explained about the big data and other things. So I was just keenly observing all the things, how he has managed the PPT and what all contents was there. So we got to know more insights about the industry, how they are handling the data, and how predictive and preventive maintenance strategies can also be put down. Just to the conventional methodologies everybody study, but see, without, I believe I'm open to the forum to speak about it. Like without intervene of the industry, academia is nothing today. So whatever we take from the industry is very much valuable, and same things should be carried forward to the students. And I appreciate the patience of the audiences as well. Like they might have noted on so many things today, and we really are thankful to the Atal Idea Lab at the AICT who gave us this opportunity to conduct the program and chosen us being the speaker here. So I'm brilliantly going Gopal sir, Rakesh sir, Raghu sir, Gautam sir, entire mechanical department. So keep doing this, and we are expecting more learning from more sessions in the days to come. So thank you once again, and it was just positive feedback from my end.
Thank you, sir.
Thank you, sir. Participants, tomorrow, day 3, we are having the two session speaker. The first session will be handled by Dr. Steenar, MK, Professor, Associate Professor, Department of Mechanical Engineering, New Horizon College of Engineering, Bangalore, in the topic of additive manufacturing, and continue that session. The second session, which will be handled by Dr. Nagendra Jairam, Associate Professor, Department of AML, Acharya Institute of Technology, Bangalore, in the topic of 3D printing in modern industry. So as usual, tomorrow, the day 3 meeting will be started 6 p.m. So I request all the participants, so you can join in this meeting. The separate Zoom link will be shared in this same group. So through mail also, we are sharing the Zoom link as well as WhatsApp link also. So kindly join in the session tomorrow. Thank you, one and all.
Thank you, sir.